Let's look at the ratio test to prove convergence for series. I'm going to make this video assuming you have done ratio test before and you need a refresher and an example, and then you want to try some. If you haven't seen ratio test before, I will provide a link at the end of this that goes through a more detailed explanation of what we're doing and why, but this shouldn't be the first video in ratio test you're watching. All right, ratio test says that if we take the next term in the series, we call it the n plus first term. So you see I'm just going to replace the n's with n plus 1's. And we divide by the nth term, which is what we were given, the nth term. Now, dividing by a fraction, of course, is the same as multiplying by a reciprocal, so I'm just going to do that. And at the end of this ratio, we're going to take the limit of this ratio and see what happens. I like to do a little bit of algebra. I like to say, well, e to the n plus 1, that's the same as e to the n times e to the first. So then the e to the n's divide out and just leave me with e to the first in the numerator. N plus 1 factorial is the same as n plus 1 times n factorial, all the numbers below it. So those divide out and leave me with just an n plus 1 in the denominator. I take the limit as n goes to infinity. And of course, e is a number, so I've got a number on top and n plus 1 on the bottom. This is going to 0. And as long as this limit is less than 1, we have a convergent series. Less than 1 converges, greater than 1 diverges, equal to 1, you should use a different test. Okay? And again, I would watch a video that is a slower explanation of this, but we're just trying to show that as you go to infinity, a term divided by the 1 in front of it will consistently be showing that they're getting smaller, and that's why the less than 1 is so important. Okay? All right, n plus first term divided by the nth, so I'm just going to go straight to multiplying by the reciprocal, and I'm going to take the limit of this ratio. Well, I have 1 extra 4 in the denominator, so I've got n plus 1 over 4n. I take the limit as n goes to infinity. It's 1/4. It's less than 1, so this converges. Anytime it's less than 1, converges. Greater than 1, diverges. All right, here are two problems where ratio test would be the best way to go. We typically use ratio test when we have a mixture of function types. You know, this is power, this is geometric, this is factorial, this is geometric. If they're the same function types, you should use limit comparison test, which I can also link at the end of this video. Pause here and try those two. All right, here's my work. I would take the next term. Divide by the nth, so multiply by the reciprocal. I'm going to have a leftover 3. I'm going to have an n plus 1 on the top. So n plus 1 over 3. When in doubt of your simplifying, especially with factorials, plug a number in. If you plugged it like 10 in, and you had 10 plus 1, so you had 11 factorial divided by 10 factorial, well, that would be 11, because everything else would divide out. So that's why we're just left with that n plus 1. Now here, all of the power is in the numerator, so the limit's infinity. Well, that's bigger than 1, so this diverges. This next one, we're going to have n plus 1 squared, 2 to the n plus 1, multiplied by the reciprocal. We're going to take the limit as n goes to infinity of this ratio. Well, I've got one additional 2 on the denominator. And if you multiplied the numerator out, you would have n squared plus 2n plus 1. Really, all we care about is the fact that the biggest term is an n squared. Well, the limit there is 1/2. And that's less than 1. So this converges. Again, if you want to see more examples, a little slower run through of ratio test, I'll put the link here. Please like and subscribe for more Try It videos.